A few things to learn about machine learning. Hi everyone, this is Mercy Madhuri K. I'm here to present a few topics, a few information about machine learning. Machine learning algorithms can generalize from examples. This is better than manual programming because machine learning systems can automatically learn programs from data. For machine learning, if more data is available, more problems can be tackled. And machine learning is widely used in computer science and other fields. In the last decade, machine learning spread rapidly throughout. Machine learning is used in web search, spam filters, recommender systems, and ad placement, credit scoring, fraud detection, stock trading, drug design, and many other applications. A brief introduction about machine learning. This is a brief introduction about machine learning. Though a lot of textbooks are available on machine learning, much of folk knowledge is required to develop machine learning applications is not present in those textbooks. Therefore, we are able to produce less than the ideal results. So there are many types of machine learning exist, but most mature and widely used one is the classification. Some terms used in machine learning are classifier, learner, training set, etc. And here are the definitions. A classifier, it is a system that inputs typically a vector of discrete or continuous feature values and outputs a single discrete value, which is the class. Therefore, it takes an input which is in the form of a vector and produces an output which is a class. Example of a classifier is a spam filter that classifies email messages into spam or not spam, and its input may be a Boolean vector. A learner, the definition of a learner can be a computer system or a machine. A learner inputs a training set of examples where they are the observed input and and it outputs a classifier. Here we denote the input and output with the variables x and y. The test of the learner is whether this classifier produces the correct output for future examples. So that is the spam filter, whether it correctly classifies previously unseen emails as spam or not. The definition of a training set. A training set is the data on which your model is built. It is usually manually written, and your model follows exactly the same rules and definitions given in your training set. Test set is the definition of a test set. The test set is the data set on which you apply your model, and if it is working and giving expected or desired result or not. It is like a test your model. So there are a lot of machine learning algorithms. If you take any machine learning algorithm, it has the three components. They are the representation, evaluation, and optimization. So all machine learning algorithms have three components. Representation, the classifier written in the formal language, the computer can understand. The classifier is written in a formal language the computer can understand. Choosing representation for learners is choosing set of classifiers that it can possibly learn. The space is called hypothesis space of the learner, and it is all about how to represent input and what features to use. And the evaluation function is also called objective function or scoring function. It is needed to distinguish good classifiers from bad ones. The evaluation function is used internally by the algorithm, sometimes differs from the external one that we want the classifier to optimize for ease of optimization and due to some issues. The last step is the optimization. We need a method to select among the classifiers in the language for the highest scoring one. Most textbooks are organized by representation. Some choices in machine learning project may be even more important than a choice of learner. Now we'll discuss about the generalization. In machine learning, generalization counts. The original meaning of generalize is to state an opinion about a large group that is based on a smaller number of group within that group. So that is to form a general opinion. The fundamental goal of machine learning is to generalize beyond examples in the training set. It's because we may not use the same examples again at test time. Example is if there are 10 words in the dictionary, the spam filter described above has 2 power 10 possible different inputs. Most common mistake among machine learning beginners is to test on the training data and have the illusion of success. So contamination of your classifier can occur by test data in insidious ways. This can be mitigated by doing cross-validation, that is randomly dividing your data into 10 subsets, holding out each one while training the rest. Testing each learned classifier on the examples it did not see and averaging the results to see how well the particular parameter does. In the next slide, we'll see how data is not enough for the learner. Every learner must embody some knowledge or assumptions beyond the data. It's given in order to generalize beyond it. Walpert says no learner can beat random guessing over all possible functions to be learned. Induction is what learners do. Deduction turns a small amount input knowledge into a large amount of output knowledge. Machine learning can get something from nothing. What it does is get more from less. Machine learning can't get something from nothing. what it does is get more from less. And a writer says, like farmers combine seeds with nutrients to grow crops, learners combine knowledge with data to grow programs. Now we discuss about overfitting. When knowledge and data we have are not sufficient to completely determine the correct classifier, we run the risk of just hallucinating a classifier or parts of it that is not grounded in reality and is simply encoding random quirks in the data. This problem is called overfitting and is the bugbear of machine learning. Example, when your learner outputs a classifier that is 100% accurate on the training data but only 50% accurate on the test data, when in fact it could have output just one that is 75% accurate on both. It has overfit. So it can come in many forms that is not obvious. Overfitting may come in many forms that is not obvious. We decompose the generalization error into bias. It's the learner. Bias is the learner's tendency to learn the same wrong thing, and variance is the tendency of the learner to learn random things irrespective of signal.